Alright, sure. Since I come with our questions, can Newtons? I'm taking a question a similar to the questions that says focus kuwo. Okay, so the question, we are given an object on a rough horizontal surface. Remember, we want to focus on how do we resolve if force apply at an angle. Okay, so la kule document question 7 uthi a learner constructs a push toy using two blocks with mass 1.5 kg and 3 kg respectively. The blocks are connected by a massless intangible cord. The learner then applies a force of 25 newtons at an angle of 30 degrees to the 1.5 kg block by means of a light rigid rope, causing the toy to move across a flat horizontal surface as shown in the diagram. The coefficient friction between the surface and each block is 0.15. Okay, so we are given the coefficient of a frictional force. Okay, and then which will state Newton's second law of motion in weight. Okay, by now funa busuyakwazi ke. Okay, but use exam guidelines ukuze ukwazi ukustate correctly. But sitting when a net force or when a resultant force acts on an object, the object will accelerate to the direction of the force at an acceleration that is directly proportional to the mass, that is directly proportional to the force and inversely proportional to the mass. Okay, so I won't write it down. Then 7.2, it calculates the magnitude of the kinetic friction, frictional force acting on the 3 kg block. Okay, so we want a frictional force acting on a 3 kg block. Okay, we know that coefficient is 0.15. Okay, that is 7.2. That is 7.2. Okay, so for a 3 kg block, so for a 3 kg block, is now for a 3 kg block. So we have a block on a flat surface, which you could see there is a normal force perpendicular to the surface. Okay, and then we have a force of a gravity, okay, perpendicular to the surface, and then we have a tension. Remember with the tension is it for a tension is fair question. So this cord is pulling the 3 kg block to the right. Right. Okay. So we have tension pulling a block to the right, and then we have another force opposing the motion, frictional force. Okay, so it was calculated if friction. It was calculated if friction. And how do we calculate a friction? Okay, so we know that for a frictional force we use a coefficient of nu k times normal force. Okay, simbala kanjani normal force? We're going to use our forces that are perpendicular to the surface. Okay, so for perpendicular forces, F net semazi ukuthi ulingana no 0 newtons. Okay, 0 newtons, not on. 0 newtons. Why is it no 0 newtons? Because the object will accelerate to the right. It won't accelerate upwards or downward, which means the acceleration ubani is 0. Okay, so mapping our forces esiwabonayo that are acting vertical. So we have normal force. Okay, as it's upward as positive, I always use upwards as positive for a consistent. So Fn positive minus Fg is equal to 0. Then Fn uyalingana nobani no Fg. Okay, then ubani ku normal force Fg if sikhuluma ngelokhuzana nge-gravity sithi ilingana ni ne-mass ne-acceleration a constant. Okay, so this is 3 times 9,8. So izothi i-answer so 3 times 9,8, that is 29,4 newtons. But we already know that mu k, we are given mu k, but say mu k we use 0,15 times 29,4, and then our frictional force will be 4,41 newtons. Okay, so this is mu k that we are given. We are given a coefficient a 0,15. Okay, so we know a formula friction it's mu k times normal force. Okay, so we know mu k, we know normal force, and then there was what is it all a friction. Okay, let's go straight to 7.3. 7.3 basifunani bathi draw a labeled free body diagram showing all the forces acting on the 1.5 kg block. Okay, for the purpose of the video, ngifuna ukuthi ibe yinde kakhulu. I'm going to draw ama diagram abe mabili kuphela. Okay, so 7.3, we have the object. Now object it is being pulled. Okay, asiqale sithi ipushwa to the east and downwards. Sayibona leya lokhuzana leya and luthi iya downwards. Okay, and then we have a normal force because the object is in contact. Once the objects are in contact with the surface, kuba khona bani normal force, and the normal force uhlale njani perpendicular to the surface. Okay, so this is FA, and then we have gravity. Okay, and then we have tension, kunye friction. Okay, so ukuze sizokwazi ukuthi sibe nelokhuzana, so this is ilokhuzana ozoyisubmit for how many marks? For 5 marks. For 5 marks, this is if you put the diagram we submit. So this is 1, 2, 3, 4, 5. By now this is the squares which siyenze. Okay, and then ukuze ukwazi ukuresolve ukuthi uthole le calculation esibili kumele sikwazi ukuyenza, we are joining la ama components. Okay, so this is our angle, our 30 degrees angle lapha. Okay, so asibala ama components. Okay, so this is your F A perpendicular. This is your FA parallel, and this is your FA. Okay, so what is side opposite FA perpendicular? So sine 30 would be opposite over hypotenuse So what is opposite? This is our FA perpendicular divided by a hypotenuse side. The side is opposite to 90 degrees. That is FA sine 30. And then we cross multiply. Okay, FA bese unikile kwathiwa 25 newtons. So we can cross multiply. So we know FA sine 30 is equal to FA perpendicular, which is then 25 sine 30 equals to FA perpendicular. So this is how we resolve our components ethu. Sitheni, the purpose of ukuthi siyenze kanje lelokhuzana sibe nama triple diagram awu3 which mase senza le esibili le esesi resolve ama component singawugesi uFA perpendicular singamgesi no FG perpendicular kuthi konje uhamba no sine umhamba no cos ngasonke isikhathi sizobala sithole answer so that we will be accurate and correct. Okay, siphinde sizosebenzisa i-trig ratio ka cos 30 ezothi adjacent over hypotenuse. Okay, adjacent in this case it is FA parallel over hypotenuse, which is FA. Okay, and then we cross multiply, we get FA cos 30 is equal to FA parallel. Siyamazi FA ubani 25. So this will make a solution yethu ukuthi ibe lula sikwazi ukuthi sifike kwi solution asadingi ukuthi siwacabanga ama component. Okay, and then sithe le you don't submit le enamalokhuzana i3, but you can submit le. Sitheni sizoba no normal force, sino normal force, sizoba ne force eya to the right because sithe la ubani ulokhuzana southeast. This is southeast, so we have the force a lokhuzana pusher to the east side, which is FA parallel, and then sibe nalama forces ayi2 ayisa down, which is FG skunye no FA perpendicular, and then we have FK, we have tension. Okay, so for a calculation, this is if we put a diagram so it's this for a calculation. Okay, I hope akekho umuntu osalayo. If kukuthi uyasala, can go back kuma video a previous sibone ukuthi uyakwazi ukuthi catch up. Okay, then 7.4, calculate the magnitude of the 7.4.1 kinetic friction acting on the 1.5 kg block. Remember, it's in a coefficient lapha EU 0.15. Okay, so sesibuyela kuningi manje, sesibuyela ku normal force nakho 7.4.1. Okay, 7.4.1. Okay, 7.4.1 sikhuluma ngayiphi block? Sikhuluma ngo 1.5. Okay, let's calculate normal force. Okay, let me write a formula. Fk mu times normal force. Okay, siyamazi mu ukuthi u 0.15 and then normal force kumele simbale. Okay, so how do you calculate normal force? Sibuyela kwini free body diagram calculation. So these are forces that are acting perpendicular to the surface. So we can only use lama forces that are acting perpendicular to the surface because normal force utholakala kuloma forces. Okay. Okay. So perpendicular forces. So I'm only writing with perpendicular forces for the purpose of a video. So that's so emphasize at the point with for perpendicular forces, you know that F net is equal to 0. Okay. So mapama forces says in our be careful. We have normal force upward is positive. So we have Fn. And then we have two forces downward. We have Fa perpendicular, and then we have Fg. Okay. Sesiyamazi Fa perpendicular. Nangu Fa perpendicular. Okay, let us make Fn subject of the formula. Nangu Fn ulingana no Fa perpendicular plus Fg. Okay. Ubani Fa perpendicular sithe uyu 25 sin 30. So this is 25 sin 30 plus Fg nayo imese sinayo uyu 1.5 9.8 times 1.5. So this is total normal force. Okay, so which is 25 sin 30. Ungalenzi put social calculator. Okay, so before we equal sign in motion calculator, check ukuthi ubhale into correct. Qala 27.2 newtons, that is our normal force. Okay, besimfunelani konje normal force. Sibuyela kwiformula yethu. Therefore, Fk is equal to mu samazi 0.15 times 27.2. So times 0.15, we get a friction as 4.08 newtons. Okay, so sesinayo if friction yabani ya 1.5, and we do have a friction got 3 kg block. Okay, I think our last question. This is a document esindala esebenziswa abafundi sathenje for the purpose of the video kuphela. Okay, so 7.4.2 to calculate the magnitude of the tension in the cord connecting the two strings. So we want to calculate in tension. Okay, so singaqala ke sibheke u3 kg block, sibuye sizobheka ubani 1.5 kg block. Okay, Okay, this is 7.4.2. It's in njalo so palo it's 4 3 kg block. Yes, now la 3 kg block. We do have a free body diagram. We do have a free body diagram lapha. Sinani lapha we have tensions kunye nani ne friction. Okay. So say the direction of motion must be positive. Kuthiwe lapha object accelerator to which direction? The object here to the direction of a force. So lama blocks way two are to the direction of the right. Okay. Kusho Newton's second law. Kumbulu second law would say when a net force acts on an object, the object will accelerate to the direction of the force. Okay. So with tension also positive because it said the direction of the right must be positive. So let's write F net. F net is equal to MA. Okay, but we are using our forces and man. We are using our forces that are parallel to the surface. So saying our forces are parallel to the surface. Acceleration, it is not equal to 0. Acceleration is not equal to 0. Okay, so tension positive minus a frictional force that is calculated is equal to mass times acceleration. Tension asiyazi, so tension minus 4,41 is equal to 3A. Therefore tension is equal to 3A plus 4,41. This is equation 1. Okay, so this is frictional forces sambala earlier. Okay, so for block for 1.5 kg block, for 1.5 kg block. Now if you put a diagram for forces that are acting parallel, tension forces that are acting parallel, it's a direction of motion benjani is positive. Remember, the direction of motion for both objects is sign benjani ifan. So we have FA parallel minus friction at the minus tension is equal to MA. Okay, FA parallel, siyamazi FA parallel nangu FA parallel. So FA parallel way to 25 cos 30. So this is 25 cos 30 minus the friction ebesibalile sathola 4,08 minus tension is equal to 1,5 A. Okay, and then sihlanganise lokhu 25 cos 30 minus 4,08 is equal to 17,57 minus 1,5 A equals to T. This is our equation 2. Okay, last part. We have equation 1 elingana no 3. Okay, we have equation 1 lana with equation 1 elingana no 3A plus 4,41. We have equation 2 which here elingana no 17,57 minus 1,5 5a. So equation 1 lingana equation 2 because they are both equals to t. Okay, so let's do that. Okay, so city 3a plus 4,41 is equals to 17,57 minus 1,5a. Okay, so this plus this would be 4,5a equals to 17,57 plus 4,41 or minus 4,41 because yeah, the sign is a change, and this is 13,16, and then we divide both sides by 4,5. We get the acceleration as 2,92 meters per second square. So once we get the acceleration, and then we go back to equation A1, let's take this equation and get the tension. Therefore, tension ibilingana nobani no 3a plus 4,41. So this is 3 times 2,92 plus 4,41. Make sure the calculator yakho uyachekisisa ungasubstitute into wrong, and then tension esiyitholayo ilingana no 13,17 newtons. So this was not a question ethanda ukuthi ibe nzima, ukuthi kumele ulandelisise ama basics akho. What is important kakhulu ikona ukwazi ukuthi si resolve these components. Sikwazi ukuthi sisuke from having a force that is acting diagonally, si resolve sibe nama forces are acting parallel to the surface only, nama forces are acting perpendicular to the surface only. And then we remember ukuthi for lama forces lawa u-F net wawo ulingana no 0. For lama forces u-F net wawo, the acceleration is not equal to 0. Make sure that you master our basics. Do not go for our question papers without understanding a free body diagram yakho. Once wakwazi ukuthi uwenze free body diagram, keep our components, kuzoba easy because our questions athanda ukuba similar. My questions ayafana, but we will always make the same mistakes because siyagesa la ama component right ngikhohliwe, and then upenalize kanjalo. So sizoyishiya lapho ivideo namhlanje, and then okwamanje ke sesizobheka ama question la esithi khona ama objects they are hanging, because those are one of the easiest questions ku Newtons. And then later ke sesibuye la sesizowenza ama questions athinta i-incline. So these are questions engifuna ukuthi in the next 2 or 3 videos sike siwabheke. Okay, my questions are kanje. Maybe we do the question nje where ama objects they are hanging, awasathintile manje surface, awasathintile surface, so there's no normal force. How do you go about solving lama questions? Okay.